Hello everyone, welcome back to CMME Made Easy, and I hope you all are doing very well. Before we begin, let me remind my dear students that the contents of this channel are only to supplement your knowledge, not to replace the regular online and offline classes in your institution. So please attend your classes and do not miss them. Also, if you like our contents, please subscribe to our YouTube channel, like the videos and share these videos with your friends, with your batchmates, with your juniors. Also, if you are a teacher, then with your students. Please follow our Facebook page and the link will be given in the description. Today we are going to discuss about measures of central tendency. In a given dataset, we have multiple observations, and these observations can be described using two summary measures, which are measures of central tendency and measures of variability. Measure of central tendency means concentration of data around a particular value. Measure of variability is a different topic altogether, and in our next video we shall discuss measure of variability in details. Now, in a data set where we have multiple observations, we are rather interested to know about the average value, and the average value is that value in the data set around which other values are distributed. This is known as central tendency because the value is in the center, somewhere in the center of the data, and around which other values are concentrated. So central tendency gives us centrality measures of the data set, that is where the observations are concentrated. The different measures of central tendency are mean, median and mode. Mean can be of three different types: arithmetic mean, geometric mean and harmonic mean. But in medical science, geometric and harmonic mean are rarely used. So that is why whenever we shall mention mean, we actually mean the arithmetic mean or the average. Now, each measurements of central tendency, which can be a mean or median or mode, all of them are unique in terms of calculation. That means how we calculate them, their applicability, their merits, demerits and limitation. Now let us start the first measure of central tendency, that is the mean. And as I mentioned earlier, when we mention mean, we actually mean the arithmetic mean. This is the most widely used measure of central tendency. This is the most commonly used measure. Not applicable for categorical data which are expressed using nominal and ordinal scale, but suitable for data belonging to the interval and ratio scale. So in my previous video, I already discussed nominal, ordinal, interval and ratio scale. So by now, I hope you all understand what these individual scales mean. There are some examples mentioned here. Suppose you're talking about gender, which can be either male or female. So they are categories and they are mutually exclusive. I could even write female before the male, and the order does not matter here. So that is why this is the example of a nominal scale. Also blood pressure, which can be normal, prehypertensive and hypertensive. Here the categories are mutually exclusive, but you can see there is a certain order. So that is why this is ordinal scale. Temperature in Celsius, which can be 40, 50 or 75 degrees Celsius. So this is an example of interval scale because 0 degrees Celsius does not actually mean absolute zero. So this is why this is interval scale. Whereas body weight, which can be 60, 80, 90 kg etc., they are example of ratio scale because 0 kg actually means absolute absence of any weight. So that is why the last two examples are interval scale and ratio scale consecutively. In case of nominal and ordinal scale, we cannot use arithmetic mean or mean. So that is why red cross has been put beside each example. And in case of interval scale and ratio scale, we can use mean. So that is why green tick marks. Now this is most suitable for data following normal distribution. When a data is following normal distribution, that means the observations in the data following normal distribution, mean is the most suitable measure of central tendency. Now many of you may be confused, what do I mean by normal distribution? Let me tell you, this is a completely different topic that needs further explanation, and in my future video I shall definitely talk about normal distribution. This is very important. For the time being, just remember that if a data is following normal distribution, we can use mean. Since mean is calculated using all observations, it is used for statistical test. So we shall see only in case of measurement of mean, we shall consider all the values or all the observations in the data set. And that is the reason for statistical test or test of significance, when the data is following normal distribution, the mean value is sometimes used. For example, t-test, paired or unpaired t-test, etc. It is the only measure of location where the sum of the deviations of each value from the mean is 0. So if we have a data set, then we can calculate the mean value from the data set. Then we subtract individual values in the data set from the mean. That will give us the deviation of each value from the mean. Now if you add up all these deviations, the total value should be 0. It may sound a little bit complicated, but in a couple of minutes I shall definitely describe this sentence with an example. How to calculate mean? Mean is calculated by summing up all observations and then dividing it by the total number of observations. So this is basic elementary level mathematics that we learned in our school. In the numerator, we have sum of all the values of the observations, and in the denominator we have total number of observations. So we have to consider all observations here. The values of each and every observation is added up to get the numerator, and that is why in the previous slide I mentioned mean is calculated by using all observations. So this part is explained here. Now this is an example of calculation of mean. The serum cholesterol level in milligram per dl of 10 subjects were found to be as follows. Then we have 10 values here. So what is the mean serum cholesterol levels? So in the numerator we have added all the 10 observations. So these individual values are my individual observations, and their values are added up, and it is divided by the total number of observation. It is already mentioned that there are 10 subjects. If it was not given in the question, we could have just counted how many values we have here. So the average is 219.2 mg per dl. Always remember, mean has the same unit as the individual observations. This is important. Now this is another example. Number of correct answers given by 5 students when they were asked 5 questions are 1, 2, 3, 4 and 5. So suppose we want to take a Viva exam and we will be asking the same 5 questions to 5 different students. The first student, he was able to give 1 correct answer. The second student, he was able to give 2 correct answers. Like this, the fifth student was able to give 5 correct answers. Now we can measure the average number of correct answers, or the mean correct answers given by each student. For that we have to add them up. That means the total number of correct answers given by all students. So 1 plus 2 plus 3 plus 4 plus 5 divided by total number of students, which is basically 3. So on an average, each student gave 3 correct answers. Now we can calculate the deviation of values from the mean. So mean is 3. The first student gave 1 correct answer. So mean minus the value is 3 minus 1. So this is plus 2. Similarly, the second student gave 2 correct answers. So 3 minus 2 is plus 1. So like this, 3 minus 3 is 0, 3 minus 4 is minus 1, and 3 minus 5 is minus 2. If we add these deviations of individual values from the mean, we shall see that the result is 0. So that is why we mentioned earlier, it is the only measure of location where the sum of the deviations of each value from the mean is 0. Now what is an outlier? An outlier is any value that is numerically distant from most of the other data points in the data set. So when you get a data set where we have multiple observations, so multiple values, we shall see most of the values are very close to each other, but there may be couple of values or few values there which are either very big or very small as compared to the other values. These values which are numerically distant from most of the other data points or other values in the data set, they are known as outliers. So also known as extreme value or wild data point. Mean is affected by outliers. So if we have any outlier or extreme value in the data set, the mean is going to get affected by it. So that is why mean is not a suitable measure of central tendency for a dataset with outlier. In that case, median is the better measurement. Now let me give an example. The body weight of 10 students are 48, 52, 46, 58, 60, 59, 54, 104, 62 and 50 kg. So we have the body weight of 10 students here, and if we look at this, the values like 48, 52, 46, all of them are very close to each other. But there is one particular value 104 which is very large as compared to the rest of the values in the data set. So that is why we can say this 104 kg is an outlier in the given data set. Now if we calculate the mean value of all these 10 students, the mean body weight will be 59.3 kg. Now I have not shown the calculation here, you can calculate it yourself, but the mean value or mean body weight of the 10 students will be 59.3 kg. If we ignore the 104 kg body weight, so this particular student is ignored and the average body weight of rest of the 9 students are measured, you will see the value will be 54.3 kg. So as you can see, the value changes by a huge margin, almost 5 kg changes only by subtracting or excluding one outlier. If there are multiple outliers, there will be much more difference between the mean values when the outlier is considered and when the outlier is not considered. So that is why we mentioned in the previous slide that when we have an outlier present in a data set, the mean value is definitely going to be affected by it. Now let us learn the second measure of central tendency, that is median. When all the values in a given data set are arranged either in ascending or descending order, then the middlemost value in the given data set is the median. That is why we can say median divides the entire data set into two equal parts. Median is suitable when one or more of the lowest value or highest value are wide apart and not so evenly distributed. Similarly, as I mentioned, that if we have outliers, that means a value that is very small or very large as compared to the other values in the given data set, mean is not a very suitable option for measuring the central tendency, and in that case median is the best option. Median does not depend on the number of observations and all the values are not considered while calculating the median. In case of mean, we have to add all the values in the observation or in the data set, but in case of median we do not need to consider all the values or all the observations in the data set. Median is computed for data measured in ordinal, interval and ratio scale. So if you remember, mean is calculated for data measured in interval and ratio scale, but in case of ordinal scale we can use median. Mean cannot be used in case of ordinal scale. How to calculate median? First, data are arranged in descending or ascending order of magnitude. Now this is very important, and I have seen many students making this particular mistake, and because of that their answer is always wrong and they do not get the 5 or 10 marks that they can easily get if they do the calculation correctly. So first step is always arrange the data in ascending or descending order. That means either in increasing order or decreasing order of magnitude. This is the first step and the most important step. Then we have to locate the middlemost value in the data set, that is the median value. Now how we are going to find the middlemost value in the data set? We can have odd number of observations, like maybe 5 observations, 7, 9, 11, like this. In that case the middlemost observation is taken. But if we have even number of observations, like maybe 10 observations, 14 observation, 20 observation, in that case we have to find the two middle values in the data set and we have to take the average of them. Now how to find the middle value? This is what we have to remember. When the n is odd, that means either 15, 21, 47, like this, then n plus 1 divided by 2 is the middle value. Whereas if the n is even, that means maybe 10 observations, 16 observations, 20 observations, like this, in that case we have to take the average of n by 2th value and n by 2 plus 1th value. Now this again may appear a little bit confusing, but let me give an example. So first we shall calculate the median for odd number of observations. So body weight of 9 students are given here, 50, 53, 76, like this. So all of them are given in kilogram. First step is we have to arrange them either in ascending or descending order. It is very common to arrange the data in ascending order, that means starting from the lowest value up to the highest value. So we have 50, 53, 59, 64, 65, 68, 69, 70 and 71. So we have all the values here. Now the number of observation is 9. So 9 is basically an odd number. So in that case we shall take the n plus 1 by 2th value. So n is 9, 9 plus 1 is 10, 10 divided by 2 is 5. So median value is the n plus 1 by 2, that is fifth. Fifth observation in the data set is our median value. So starting from the lowest value 1, 2, 3, 4 and 5. So this is our median value. So in the given data set the median value is 65 kg. Right? Let me just explain this, or rather repeat this again. Since the number of observation is odd, we have to follow this formula. We have to find out the middlemost value. How we are going to find the middle value? Using this formula when the total number of observation is odd. So n plus 1 divided by 2 when n is odd. In our example we have n equal to 9. So 9 plus 1 is 10, 10 divided by 2 is 5. So fifth observation is our median value. So 1, 2, 3, 4 and 5. So this is our median value in the given data set. Now what we have? Even number of observations. So we have serum cholesterol level in milligram per dl of 10 subjects. Again the first step and the most important step is to arrange the data set in ascending or descending order. Now just let me go back to the previous slide. Suppose we forgot to arrange the data in ascending or descending order, right? We forgot this step. We know that we have to take the fifth observation to get the median value. So in that case 1, 2, 3, 4, 5. This is the original data set. The question as it was given to you. So 1, 2, 3, 4 and 5. So according to this the median value should have been 68 kg. But you know, if you arrange them in ascending or descending order, 65 is the correct answer. So 68 would be the wrong answer. So please don't make this mistake. Don't skip this step. Always arrange your data in ascending or descending order. Coming back to the second example again. So we arranged all the values here in ascending order. Now the total number of observation is 10, which is an even number. So for even number of data we have to follow this formula. We have to find out the n by 2th value and n by 2 plus 1th value. So if n is 10 in our example, so n by 2 is 5th value, 10 by 2 is basically 5th value, and n by 2 plus 1. So 10 by 2 plus 1, 10 by 2 is 5 plus 1 is 6. So 6th value. So 5th and 6th value we have to find out. Then we have to take the average of the fifth value and sixth value in the given data set. So we have 1, 2, 3, 4, 5. Fifth value is 212 and the next value is the sixth value, that is the 218. So you have to take the average of 212 and 218, which is basically 215. So in the given data set, the median value is 215. Let me repeat this step again. First we arrange the data set in ascending order. Then we see how many observations we have. Since we have 10 observations, which is an even number, we have to take the middle two values in the given data set. So first value will be n by 2. So 10 by 2 is basically fifth. So fifth value. And the second value will be n by 2 plus 1. So basically fifth value and the next value. You can also remember like this. So fifth and sixth value we have to find out. So in the data set, the 1, 2, 3, 4 and 5. So this is the fifth value and this is the sixth value. So we have to take the average of the fifth and sixth value. So average of 212 and 218 is 215. So that is why the correct answer is median serum cholesterol level in the given data set is 215. Next is the third and final measure of central tendency, that is mode. And this is the least commonly used measure of central tendency. Now what is a mode? If we look at a particular data set, we can see maybe one value or more than one values keep repeating itself. That means it can be present more than one time in the given data set. So the particular value which repeats itself most of the time in the data set is considered to be the mode in the given data set. If you are dealing with nominal scale or any data that can be classified using nominal scale, then we have to go for mode. That is the only option. If you are dealing with ordinal scale, then median is the only option. If you are dealing with interval and ratio scale, we can either go for median, but the best option is going for mean value. Advantage of using mode is it is not affected by extreme values, just like median. But if you remember, if there are extreme values like outliers, it can affect mean value. Disadvantage is exact location is uncertain and not clearly defined. So whenever we measure the central tendency, it is expected that we shall get certain value somewhere at the or around the center of the data set. But whenever we are measuring the mode, it may or may not be at the center of the data set. It can also be at the side or at one end or either end of the given data set. So it may not be at the central position. So that is a disadvantage of using a mode. Coming to the first example, we have given the body weight of 10 children in kilogram. So 12, 14, 15, 14 like this. In case of measurement of median, we arrange the data in ascending or descending order. But if we are dealing with small number of observations, it is not necessary to arrange them in ascending or descending order while calculating the mode. But it will always be helpful to you to arrange them in ascending or descending order, especially when you are dealing with a large number of observations. In this given example, we have only 10 children, so 10 observations, and if we look at the observations here, we shall see the most repetitive value is 14. So we have 14 here once, twice and thrice. So in the given data set, we have 10 observations. Out of this 10, we have the value 14 repeating itself thrice. So that is why the mode in this given data set is 14 kg. Always remember, the unit for mean, median, mode will be same as the unit for the observations given in the problem. Example number 2, weight of 14 children in kilogram are given here. Now if we look at the values carefully, you shall see the value 12 and 16. These two values have repeated itself most of the time. So 12, the value 12 we have once, twice, thrice and fourth time. What about 16? Once, twice, thrice and 4 times. So as you can see, in this given data set of 14 observations, value 12 has repeated itself 4 times, value 16 has repeated itself 4 times. So for this data, both 12 kg and 16 kg will be my mode. So here we have two values and two modes. We may come across two or more values repeating itself same number of times, just like this. So two values here repeating themselves 4 times, so same number of times. In such cases, the distribution is said to be bimodal or multimodal. Here we have two values repeating itself same number of time, and that is why this is a bimodal data, because we have two values. If we had three values here repeating itself say 4 times, all of them repeating itself 4 times, in that case we could have called it multimodal. So more than 2 is multimodal. In the previous example, since we had only one value that kept repeating itself most of the time in the given data set, this is known as unimodal. So with this, we conclude today's session on measure of central tendency. If you like the video, please subscribe to our channel and share this video with your batchmates, juniors and friends from other colleges. We also have our Facebook page that you can follow. The link is given in the description. Take care, and we shall see you in our next video.